All right. Hello, everybody. Welcome to the last video. All right. So we've made it to the end. We're going to try to put all of this together. All right. I'm going to do these two with you. We're going to graph them. I'm going to state whether it's 1-to-1. If it's not 1-to-1, we're going to state restrictions to f of x that would make the function 1-to-1. Then we're going to find the inverse. You guys can do these ones either way, algebraically or with the operations. And then we're going to state the domain and range of f of x and the domain of the inverse with the restrictions that we use from part C, okay? Now, this guy right here, 2x squared minus 8, right off the bat, I should be thinking to myself, not 1-to-1. This is a quadratic. Any quadratic without a restriction on it, not 1-to-1, okay? Now, we'll make a quick graph. Right? I'm going to start with 0 in the middle, right? Because I know 3, 4, 5, 6, 7, 8, right? So the function is symmetrical with 0, -8 at the bottom there. I put in 1, I get, what, -6. I get another on each side, right? If I put in 2, I get 0. -2, I get 0. If I put in 3, I get 10, which is off of the graph, so that's up there. Same with that over here. So, is this 1-to-1? Definitely not. Fails the horizontal line test, right? You can give an example. It's always good to do. Input of both give -6 as the output. So that's no good, right? Now, what restrictions do we need to make this work? Well, technically we can pick two, right? We could either pick this side of the graph to make it 1-to-1, or we could pick this side of the graph, right? I'm going to pick the yellow side right there, right? I like to take the positive x's, so x is greater than or equal to 0. Technically, just greater than 0 would also work, but it's not a problem if we take 0 as well. So I'll take that, okay? And that means that I'm really focusing on these values here, right? So when I make my inverse, those are the ones that I'm going to use to make it. So 0, -8 becomes -8, 0, whoops. 1, -6 becomes -6, 1. 2, 0 becomes 0, 2. And 3, 10 becomes 10, 3, which is off the graph. So I end up with this, right? Okay. Inverse equation. Well, I'm going to say y equals 2x squared minus 8. I'll do the traditional way, but there's nothing wrong with the other way. All right. I add 8 to each side. X plus 8 equals 2y squared. All right, divide each side by 2. I get y squared equals x plus 8 over 2. And now I'm going to take the square root. Now, technically, I get plus or minus. If you don't restrict anything, right, this would be the inverse relation. Plus or minus is not a function, right? If you plug in a value, right, other than one that gives you 0, but you try plugging in 1 here, right, you're going to get two numbers out because of the plus and minus. Now, we've restricted the function before, right? We restricted it up here, right? So when you're at this point, you might want to ask yourself, okay, wait a second, what were the what was the restrictions we put on this function? We said that the domain was greater than or equal to 0. It also meant that our range was greater than or equal to -8, right? So we can write range f of x is greater than -8. Actually, I also like just writing these in, and I usually just do it in an interval. Sorry about that. I like writing domain and range as an interval. Okay, so now I have to ask myself, if I'm only plugging in positive values, right? And I want them to be greater than, so I'm only plugging in positive values in the original. That must mean I'm only getting positive values out in the inverse, right? So I know my domain is -8 to infinity. I'm going to write that x is greater than or equal to -8 up here. And my range has got to be 0 to infinity, so I'm going to take the negatives out. I know when I plug in values, I'm only getting that positive. So I'm going to write it. Now I can write it as a function. Where I've taken the negatives out. Okay, and there's my domain and range. All right, so tricky little domain and range workings there, but hopefully that makes sense. And it all comes back, this is my favorite property, that we can kind of use that to analyze when we're trying to make it into a function, right? All right, let's try this one. So negative square root of x plus 3, all right? Let's make a little function here. Now, if it's a square root function, I'm only really gonna plug in things that work nicely, right? Plug in 0, because I know if I plug in -1, it's not going to work. The lowest I can plug in is 0, right? If I plug that in, I get negative of 0 plus 3, I get 0, 3. Okay. I know if I plug in 1, I'm going to get -1 plus 3, I get 2. Oops. 1 comma 2. Now, the next nice number to plug in would be 4, right? So I'm going to plug in 4. Let's see what I get. I get -2 plus 3, I'd get 1, right? And if I plug in 9, negative square root of 9 is 3, plus 3 is 0. So I can plot these here as well. 1, 2, 3, 4, 5, 6. This is just off the graph, but it's over there, right? Okay. So I've got those. My inverse we can plot in a second, but let's just take a look at this, right? Hopefully we see that this is going to go below the x-axis, right? If I plugged in negative 100, for example, we would get negative 10 plus 3 would be negative 7. So we can go below the x-axis, right? But we also realize that all we can plug in are positive values, right? So we know that the domain here, and we'll rewrite this on the bottom, has to be 0 to infinity. And our range actually goes from negative infinity up to 3 as the highest point, right? The very highest value we can get is 3. Can't go above 3, but we go all the way down forever, okay? Now, in this case, is the function 1-to-1? Well, yes. Passes the horizontal line test, right? And each output only has one input, right? So all of these outputs only correspond to one input, right? We can't take like the square root of 9 and -9 and get the same thing. We can't take the square root of negatives, right? So that one works out well. Now, restrictions are not required, right? It's sort of implied that x is greater than or equal to 0 as part of the domain, right? So I'm going to go down here and just fill in my domain and range really quick, right? this is actually really helpful to me because it allows me to fill this in automatically. If I'm going to be making an inverse that is a function, it better have these rules, right? It better have a domain of negative infinity to 3 and a range of 0 to infinity, right? It almost builds any restrictions that I will need for the inverse equation, all right? So why don't we graph this real quick, right? 0, 3 goes to 3, 0. 1, 2 goes to 2, 1. 4, 1 goes to 1, 4. And then this one's slightly off the graph, but we realize that hopefully it's going this way. Now look at something real quick here. Graphically, too, it should make sense. The domain is from 3 all the way to negative infinity, right? And the range is from 0 to infinity, right? The x-axis and up. So that checks out really nicely, right? Now all we have to do is find the inverse equation. So we'll take our function y equals negative x plus 3. We switch our x and y. And we square each side, right? So we're going to get x minus 3 squared. Now, when we square any negative, it becomes positive, and the square root of y, that's just y, right? However, it's very, very, very important that we consider this, right? Technically, if I graphed this, I would have a parabola, right? Y equals x minus 3 squared, I would have a full parabola. That is not the inverse of this function, right? In other words, if I graphed x minus 3 squared, it would look like, you don't have to write this, but it would look like this side of the parabola, right, as well, which I know I do not have. And I'm going to erase that right now, okay? So what I'm going to say is I'm going to use my domain here to make the argument, okay, that the function has an inverse that has this graph, but x is less than or equal to 3, right? Which is from the domain coming from the range, or just thinking about it as a restriction, it has to be that way for this to check out for both the inverse and the original function to be functions, right? Okay. All right, so try the rest. That's all I have for the videos. Please reach out to me for any questions. Just remember, trying to do every single one here, okay? Do them to the very best of your ability, and reach out if anything comes up. All right, and I'll see you guys soon. Bye-bye.